Om Sri Guru Basavalingaya Nama. Today we shall do some questions of reflection, because in the coming test on Sunday you will be having this portion. Then later we will go ahead with the other part, that is prisms. Now, let us see the first question over there. A man is 180 centimeter tall. So, this means height of object here. Suppose say that it is the man. Eyes will be there here. So, this thing, the distance from the top to here, eyes is how much? We will take that one as capital H, 10 centimeter. 10 centimeter. In order to see its entire height, right from top to top of the head to, he uses a plane mirror kept at a distance of 1 meter from him. The minimum length of plane mirror required will be. So, what is said to view the entire height, to see whole thing, what should be the length of the plane mirror, that has to be used. Well, now here what is been found that is, suppose we have whole length, whole height of the mirror as is the height of the object, we can see the thing, we can see the full image of ourselves. Otherwise, minimum will be how much? Minimum is this height says h. Then that height should be how much? It should be equal to half of the height of the object. So, here this is independent here. We need not consider this, we have to take half of the total height, and half of the total height means how much? 180 divided by 2, it is 90 centimeter. So, remember, whenever a object means we want to observe our complete image, what should be the height of the mirror required? The height of the mirror should be equal to height of the object. So, this is the clue we have to follow. Now, coming to the next question. This is conceptual one. Second question is conceptual. A plane mirror produces a magnification of, means magnification of plane mirror is asked. We know, suppose say we are standing in front of a plane mirror. Plane mirror, what happens? That our image will be formed behind the plane mirror, and what you will find? If say height of the object is HO, height of the image is say HI, then we know that magnification equal to HI divided by HO. But here height of object and height of image will be always same. As height of object, height of image are same, we get on here HO by HO, how much? 1. Since both of the heights are in the positive direction, we will be having here also plus, so we can get on this as plus 1. So, here what you will find that magnification will be how much? Plus 1. magnification will be +1 for a plane mirror. Now, coming to the next thing, next question. A small object is placed 10 centimeter in front of a plane mirror. So, well, again here it is a question of plane mirror. So, one object is kept at a distance, say u. U is given to be how much? U is given to be 10 centimeter. 10 centimeter. If you stand behind the object 30 centimeter from the mirror, well, we know that its image, say this is the object, its image will be formed behind the mirror at the same distance. So, we can take here u equal to v. But man is standing behind the object, and given that this distance from the mirror is how much? 30 centimeter. We will take this one as u1 equal to 30 centimeter. 30 centimeter, and look at this image. The distance focus for your eye will be. So, here what is asked? We will write down that one as v1 equal to how much? So, where the person has to focus, he want to view the image of this object. It means he has to focus over this distance. That distance is how much? v1 should be equal to u1 plus v. And you know that v will be equal to u is 30 and u1 is u is 10 and u1 is 30. We can write down here this as 30 plus 10, that is equal to 40 centimeter. So, because here he want to see the image of this object, so this distance will be 10 plus 30 will give us 40 centimeter. Now, answer is what? Answer is C here. C will be the answer. Now, coming to the next question. An object is moving at a speed of 5 meter per second. So, what is given? Velocity of object is given. Velocity of object is how much? 5 meter per second towards a concave mirror of focal length. So, focal length is given how much? 1 meter. 1 meter, and it is a concave mirror. So, we will draw the diagram here just to understand it. It is concave mirror, and say this is pole, it is focus, it is center of curvature, and this is focal length. Object is moving towards this, and well, is at a distance of 9 meter, means what? U is equal to 9 meter. U equal to 9 meter. The average speed of the image is, means speed of image Vi is asked here. Now, for this, we have to follow one clue. What? First, you will assume that that object is here, and its distance from pole will be how much? U. So, we will find out initially what is the value of V. V means image distance. It is the speed of image. Now, image distance we want, we will find out, we will use the formula 1 by U plus 1 by V equal to 1 divided by F. Now, here we have to use the sign conventions. Incident ray will be traveling like this. Incident ray, but to measure the object distance, we have to go from pole to here. So, that is why U must be taken minus. And to measure focal length, we have to go like this again, from P we have to go measure to F. So, that is why F also will be how much? Will be minus. So, now we will use those two data here. It is 1 by minus 9 plus 1 by V equal to minus 1 by 1. it will become 1 by v equal to minus 1 by 1 plus 1 divided by 9. What will happen? We get here 9 as LCM, minus 9 plus 1 will give us minus 8 divided by 9. So we will be getting as minus of 9 by 8 meter. 9 by 8 meter. Well, what we'll do here, this will be the initial case, so we'll put it here as Vi, or the I we are taking for that. We'll take here U1, V1, V1, V1. This will return as like this. So what happened? We'll be getting V1 equal to so much. Now, after 1 second, the object will be moved by how much of distance? In 1 second, object moves by distance 5 meter. 5 meter. So for that one, we will look here. We will run this one, same equation for the second case. 1 by V2, 1 by U2 equal to 1 by F. F will remain same. F is 1 by F. Now, in 1 second, object is moved by 5 meter. So it means this distance is covered. Then what should happen? Total distance initially was how much? 9 meter. So 9 minus 5, 9 minus 5 will be second distance. So we get on here U2 equal to 9 minus 5, that is 4 meter. 4 meter. Again using distance, we get on this as minus, so it will become minus 4 meter. So 1 by minus 4 plus 1 by V2 equal to minus 1 divided by 1. This, if we take it that side, we get 1 by V2 equal to minus 1 by 1 plus 1 divided by 4. We can write on this as 1 by V2 equal to 4 is LCM, minus 4 plus 1. So we get here 1 by V2 equal to minus 3 divided by 4. 3 divided by 4, what has happened now? The distance is changed. So this can be written as V equal to minus 4 by 3 meter is the second distance. See, it is not velocity, it is distances, positions. So therefore, velocity of image is what? Final position, we'll write down here, final position minus initial position. Initial position divided by time. Now if we see, final position is V2, initial position is V1. It will become minus 4 divided by 3, minus of minus will become plus 9 divided by 8, divided by, in how much of time? 1 second. So this can be written as 1 second, it is velocity of image. Well, now we'll simplify this. We get on Vi is equal to, means the velocity of image is equal to 8 3 ja 24 will be the LCM here, 8 into 3. 8 4 ja 32 plus 9 3 ja 27. So we get on that Vi equal to 24 will be here, and there minus 5 will be obtained, minus 5 divided by minus 5 by 24, 4 centimeter, minus 5 by 24, 8 4 ja 32, 9 3 ja 27, minus 5. Well, here, since if we look in the option, this type of option is not there, we can convert this as approximately how much? We can run that as approximately 25. 5 1 ja, 5 5 ja goes, this will become how much? Minus 1 by 5 meter per second, meter per second. It means image will be moving towards the mirror by this much of speed. So answer is what? Answer is first 1 by 5 meter per second. Actually 5 by 24 also is the answer, but that option is not given. So we can convert like this and choose the option. Now, let us go for next question. It is only conceptual question. A concave mirror of focal length f in air is immersed in water. Water's refractive is mentioned as 4/3. The focal length of the mirror in water. Remember here that whether the mirror is in air or in any medium, the focal length does not change. As the focal length does not change, answer will be what? It is f only. So focal length, how much is the focal length in air? The same will be the value of focal length in the water or any medium. Now, let us go for next question. A convex mirror of focal length f forms a image which is 1/n times the object. So it means given here is m equal to magnification equal to 1 divided by n. Then the distance of the object from the mirror is, it means what is asked? U is how much is asked. Now, here, well, image, we will be here getting two cases, one is real image, one is a virtual image. So, we will assume that it is a real image formed. So, in case of real image in mirror, we take a minus 1/m. Now, we can write down the formula m equal to V divided by U. V divided by U. This can be written as 1/n equal to V divided by U with minus sign. So this will become U, well, we'll write down for V. U we want, so we'll write down for V minus U divided by N equal to we'll be getting as V. Now we'll put it here in the equation 1/f equal to 1/u plus 1/v. 1/f equal to 1/u plus 1/v. V value will put it here 1/f equal to, we can write down here minus of n divided by, well, it is same that one. So it is 1/u and minus of n divided by u. Here if we take LCM, we will be getting LCM as equal to u. We get on 1 minus n. So n can be written as, u can be written as 1 minus n into f. It is one case. So one case, well, n 1 minus n is taken because focal length of convex mirror is same. Now here this is one case, but this option we are not finding there. Well, we have to take which option? Now we have to consider that here a virtual image is formed. Well, always actually in this case only virtual image will be formed. So we get on plus 1/n equal to V divided by U. V divided by U. So we will be getting here V equal to plus n by U. For real image we will be considering like this. Now we know that 1/f equal to 1/u plus 1/v. 1/v will become 1/f equal to 1/u. U will keep it as it is plus n divided by u. 1/f equal to u is LCM. We can write down here 1 plus n. So this will become u equal to 1 plus n into f. So this option will be finding over here that n equal to n plus 1 into f is the option. So remember, when the image is real, we have to take minus, virtual, we have to take plus. Now we'll go for next question. Here mention that two mirrors at an angle theta produce 5 images. Well, angle between the two plane mirrors is mentioned to be theta, and they are producing how many images? 5 images. Then the number of images produced when theta is decreased by 30 degree. It means theta 2 equal to theta minus 30 degree. So we will write this as n1. How many number of images will be produced is asked. And we know that here n1 equal to 360 divided by theta minus 1. So this will become 5 is equal to 360 divided by theta, theta 1 is theta minus 1. This if we take it here, we get 6 equal to 360 divided by theta. So theta equal to, we will be getting as 360 divided by 6. How many? It is 6, 6. So 60 degree will be the angle theta. 60 degree. Now similarly we get it on here. N2 equal to 360 by theta 2 minus 1. 360 by theta 2. 360 divided by theta 2 is 60 minus 30, because theta value is 60. So 60 minus 30 has to be put minus 1. We get here 360 divided by 30 minus 1. This goes 3 1 ja, 3 2 ja, 12 minus 1 is how much? 11. So we will be getting here 11 number of images to be formed. 11 will be the number of images formed. Now let us go for next question. Next question. A man runs towards a plane mirror at a speed of 15 meter per second. So again here what is given? A plane mirror is given and man is running towards plane mirror with a speed of, write on this as velocity of man, write on Vm, write on is 15 meter per second. 15 meter per second. Now the speed of the image relative to the man is asked. Image. So if you see the image, image will be obtained in the mirror at the same distance as the distance of the man. And speed of image, say I. How much it should be? It should be again 15 meter per second, but will be in which direction? In the opposite direction. So this can be written as minus here. Well, anyone here, since distance we will be measuring, will not take this as minus, we will be measuring the distance from here to here. If we take this one as minus and this one as plus, then what is asked? The speed of image relative to the man is asked. So V here velocity, net velocity is how much is asked? V net equal to, we get on V image minus V object or V man. V man. V image is 15 minus of minus 15 will become 30. So 30 meter per second will be the net velocity of this person, means image with respect to man. 30 meter is where this is the answer. Now let us go for next question. Well, a person wants a real image of his own 3 times enlarged. So here m is how much? Minus 3, because enlarged image is want. Where should he stand in front of a concave mirror of radius of curvature 30 centimeter? So R is given to be how much? 30 centimeter. 30 centimeter. Well, it is a concave mirror. Mention that real image in front of, means where in front of a concave mirror. So for concave mirror, the focus will be here, center of curvature will be here, means both will be in the opposite direction of incident ray. Distances will be measured like this. So F is equal to how much? R divided by 2 will be getting as minus 15 centimeter. And where should he stand is asked. It means U equal to how much? Now we know that again we can use the same formula, M equal to V divided by U. It is minus 3 equal to V. We will keep it as it is divided by U. So it will become minus 3U equal to V. We will put it in the formula that 1 by V plus 1 by U equal to 1 by F. 1 by minus 3V plus 1 by U equal to 1 by F. 1 by 3U. 1 by 3U. This will become 3U will be the LCM, not minus, only 3U. We will be getting here minus 1 plus 3 equal to 1 divided by F. 1 divided by F. Now, if we simplify this, we get 2 divided by 3U. 3U equal to 1 divided by F, or U equal to, we will invert it, we get here 2F divided by 3. U is inverted, 3 goes this side, 2 goes this side, comes here 2F by 3. This will become 2 into F is minus 15 divided by 3, so it will become 5. So answer will be how much? Minus 10 centimeter. Minus 10 means it is in front of the mirror. So we have to choose here 10 centimeter as the answer. So 10 centimeter means what? Third one will be the answer. Now, let us go for the next thing, that yesterday we have seen the prism and obtain the equation n equal to sine of A plus D divided by 2 whole divided by sine of A divided by 2. Sine of A divided by 2. Now, in this we will be having certain cases. What we will find that suppose say if we are having one prism like this and say it is a thin prism. What will be a thin prism? A prism whose angle is small, about of the order of 10 to 12 degree will be called as a thin prism. Now, here we shall see the deviation which is produced by a thin prism. So, deviation produced by a thin prism. Thin prism, well, assume that in this is a thin prism, in this these two are refracting surfaces and it is a base. Well, once again we will recall the things. Deviation produced by a thin prism will be given by what? I1 plus I2 minus A. So, this formula we had used yesterday. Then angle of the prism will be given by relation R1 plus R2. Now, we will use these two things here to obtain the refractive index. Assume that PQ is a ray of light incident at a small angle, because this angle is small, so this angle also will be small. Let us say it is how much? I1. And now this ray will refract and say travel like this. Well, say it is QR, the refracted ray. This angle is how much? assume that it is R1. Now, assume that this is incident here at small angle R2 and it emerges along that side, other side at angle of emergence say I2. Now, it is a RS ray. So, what will happen when this angle is small? All the four angles I1, R1, R2, I2 all will be small. So, as all the angles are small, if we use say refractive index of this medium is how much? N. Then we can write on N is equal to sine of I1 by sine of R1 for the first phase. Now, because of that, what will happen here? We can write on this as I1 by R1. Why? Because when theta is small, when theta angle is small, in that case, we get it on sine theta equivalent to what? Theta. So, there sine can be eliminated, we can take directly this angle in radian. So, now because of that what will happen? It becomes IR1 equal to I1, so it is equation number 1. Now, likewise, if we use the same formula for second phase, we have to take sin I2 by sin R2. So, similarly, we get it on N equal to sin of I2 divided by sin of R2. Now, again using the same, because all the four angles are small, it will become I2 by R2 or N R2 equal to how much? We get here I2, say equation number 2. Now, but if say D is the deviation produced by this particular prism, so in that case using the general formula we get it on this as I1 plus I2 minus A is the formula we derived yesterday. So, because of that we can write on this equation as D is equal to I1 is how much? NR1. So, it will be NR1 plus I2 is how much? NR2. I2 is how much? NR2 minus A. If we take here N outside, we will be getting here R1 plus R2 and minus A. So, R1 plus R2 minus A. But we know A equal to R1 plus R2. So, because of A equal to R1 plus R2, what will happen? We can write this one as NA minus A. So, here we can write on A into N minus 1. So, what we will find that if the prism is small, then deviation produced can be given by D equal to A into N minus 1 when the angle is 60 degree etc. means greater than 12 degree, then in that case deviation will be given by I1 plus I2 minus A. So, well, let us see the conditions for achromatic combination of prism etc. tomorrow. Today here we stop. Thank you.